To add the staircases load, so the load from the staircases, we need to select the edges of the openings for the staircases and add on them distributed, uniformly distributed load. So to select them, I will use the option select elements and will select two opposite parts of the um, this hole, and the four parts for the opening for elevator. Elevator. So the total load from the staircases will be 850 kilograms. 0.85. So I will restore model. Next load is the payload. Payload. It is equal 160 kilogram. Payload. The payload is short-term load. Short-term load. Payload will be added at all slabs. For selection slabs, we need to use the polyfilter by stiffnesses and select the slab. Go to loads, loads on the plates and the uniformly distributed. 0.60. Right? Right. Okay. Restore model. Next load is snow load. The normative load from snow is equal to 50 kilograms. 50 kilograms. Now I will open the explanatory note. Here I want to find information about snow. Here is information from the snow. And this is main formula to find the calculated load from snow. Calculated load from snow is find according to the coefficient K. It is about region, location of the building A, B, and C, and also the height of it. So the new coefficient will be 1, because we have no inclined covering. Our covering is a horizontal. So, and the formula will be equal to, in my task I have the first region 0.5, and all other coefficients will be, let's read the formula 5, the thermodynamical coefficient. Okay, so we will just use three of them. So we'll not thermodynamical coefficient, will not use it. We will use just three main coefficients. This coefficient, according to the horizontality or inclined surface of our covering, will be 1. It will be um, the safety coefficient 1.4, and the normative load 0.5. So we'll multiply three um, numbers between each other. 0.5 multiplied to 1.4 will be 70 kilogram 70 kilogram for 1 square meter. So 0.07. I will go to the model. We'll use edit the load cases, add the additional load. It will be snow load. Snow load, short-term load. I need to select my covering slab. And we'll add the load 0.700. Okay, restore the model. And the last loads, seismic loads. Seismic loads in X, Y, and Z direction. X, Y, and Z direction. So to add the seismic load, we need to go to this position, So seismic load is accepted according to the task. So I have the seismical activity 8 point. The soil conditions category is second. I need to put these characteristics here, but previously I will, so first of all, maybe I will do, I need to create this load. Actually, yes. So I will create it in the load, edit load cases. So I will add the ninth load, the load number 9, and we'll write here the earthquake, uh, the quake earthquake load on axis x, x-axis earthquake. We'll save it. Add the load number 10 on y-axis and the load number 11 earthquake load on axis z. 9, 10, 11. Okay, so we are going to analysis, table of dynamic load cases. Here we will write the first load number 9, then we'll choose the earthquake snip 2006. We'll use number of model shapes 10 parameters. The correction factor will be 1, seismicity 8, soil category 2, and then according to these tables we need to find all other coefficients. So to find them I will open this normative document, and the first table we need 5.2. Going to the table, this is the table number of 5.2, and so according to the characteristics of our building we will find this coefficient. So for me I will took the building like a residential building. If according to your task, for example, you will have other um, aim of the building, so you can choose other type of the coefficients. For example, if your building will be school, so you will took 1.2. For me it is a residential building, I will took coefficient 1. Directly in this table I write 1. Structural design coefficient from tables 5.3, 5.4. 5.3, 5.4. So according to the principal scheme of your building, the skeleton of your building, you accept this coefficient. So for my building, I will choose the coefficient which are showed in the second line, the frame buildings. With the frame buildings, and we'll took 0.25. So the A, if information in the A line. Zero point 0.25 structural height by using the formula number 5.3. This is a formula 5.3, and so what in this formula we need to know the coefficient p. P is the number of levels in the building which are located above the ground. In our building will consist that all of the levels located above the ground, and so according to the task I have 10 stories in my building. So in this formula I will use number 10. So 10 minus 5 will be 5. 0.06 multiplied to 5 plus 1 will be 1.3. So this coefficient in height, structural height, will be 1.3. Energy dispersion in table 5.7. Let's go open the table number 5.7. So here we see two main lines. So here is structures without walls and with the walls. Actually, in our buildings there are external walls. That's why we will use the line number 2 with a coefficient 1. Number 1. We put it here. And the last one, coefficient for soil conditions, we need to take from the table 5.6. This is table. According to the soil category, I have second category, and the seismicity of my region is 8, so coefficient will be equal to 1. So that's all. I have already finished filling this table, and according to the direction of earthquakes wave, I will choose the next scheme. So when I will add the load, seismic load in X direction, in this case I will write 1 to the CX position. When I will add to the Y direction, I will write here 1. In Z direction, I will write 1 here. And other two variants will be 0. Apply. Next one, it is 10. Number of load number 10. According to Y direction. Here is 10 analyzed model shapes. All parameters is the same, just only this one will be changed. So now according to the Y direction, we need to write here the 1. Right, here will be 0, here will be 1. Okay. And the last one, 11th. That will be 1. Okay. That's all. So we press button apply and apply. Now we need to create the load cases. So load cases with the dynamic and the static load. So each of the static loads should be included into the case with the dynamic load. There are main 8 static loads acting on our building. So we need to create with three, which is with each of the 3 dynamic load, all the static case loads. Let's start from the first one. The first dynamic earthquake load is the have number 9. So dynamic load case is 9. The number of corresponding static load will start from the 1 to 8. Looking at this table, which are given in the SNP construction in seismical regions 5.1, here we see the coefficient of the cases. For own weight, for dead weight of metal construction is applied 0.95. For other constructions which have own weight for dead load, the coefficient will be 0.9. For the permanent acting loads, it will be 0.8, and for short-term loads, it will be 0.5. So there are 3 last short-term load. It's a payload, last 2. I'm sorry, payload and the snow load. They are short-term load. The other will be long-term loads. Go to this table, creation of dynamic load cases, and we'll write 0.9. This is for monolithic constructions. Add. Second will be with the coefficient 0.8, 3, 4, 5, and the 6. 7 will be with coefficient 0.5, and the same will have 8. That's all. 10. It is earthquake load in axis Y. We need to create the same cases with the all static loads. 10, 1, 0, 9, 10, 2, 0, 8, 3, 4, 5, 6, 7 will be 0.5, 8. And the last one is 11. 1, 2 is 0.8, 3, 4, 5, 6, 7, 8. That's all. And press button OK. Now we need to add the design combinations of the load. We need to add the parameters. I'm sorry, the design combination of forces, not from loads, from forces. So here we select each of the loads and press apply. Second load, we applied the all combinations. Third, fourth, fifth, sixth, 7, 8, and 9, 10, and 11. We need to use the group of the mutually exclusive load cases. So this group will mean that each of the earthquake load have only one direction on X, Y, or Z um, direction, not from all of them in one time, from separately from each other. And we'll press button OK. So now we can say that we finished creating the main body of our skeleton. We finished adding the loads. And the last thing what we need to do is to add the coefficient number 1 and the 2, C1, C2. It is model of subgrade reaction. So let's add the model under our foundation. Now we have the rigid restraints for our foundation, but generally it is not right because under the foundation in the real conditions are located the soil conditions, and so we will create the ground soil conditions. So we'll close this snip, and to add the ground soil conditions we will use the geological report about research soil conditions. Engineer geological report. This is report was taken from the other building actually, but for us it's not so matter because we need just to right understand how we'll do it, right? We actually on other lessons we also did it the same thing, but let's see how it will work under this building. So let's go to calculation of this model coefficients. Go to calculate C1 and the C2. Um, it will be actually interesting to find the vertical load, but in general it may be if we will told that our building is rectangular and the width of our foundation is how many meters? 54 to 40. 54 to 40. Right here 54 and 40, 0.8. Maybe here I will write 40 and here I will write coefficient 1.1, 1.2, 1.3. 1 point, so the ratio between the size of my foundation is the width is 40 meters and the ratio 1.35. So the next length will be 54 meters. The depth of my foundation maybe 1.5 meter. 1.5. So next I go to geology. I will choose three layers. The first layer will have model elasticity 22. Basin ratio will be the same. The depth of the layer will be about 6.5, the biggest one. Unit weight of the soil 1.95, 97. It is silticlide type of the soil. The next one, model of elasticity will be the same. Ratio of Poisson coefficient 0.35, depth of layer 1.4, unit of weight 1.97, 1,400. And the last one, 30 model of elasticity, right, 3000, 0.35, 1.9, .96 unit weight. The sand level 1,400. Okay, maybe 80, 100 tons, 200 tons. What happened? What? With the soil properties, restraints may be imposed construction. Something. What is wrong? Let's see. Oh, here. No? That's right. That is all right. That is all right. What happened? So we need to show a really huge number of the vertical load because it is a plate foundation, and it can calculate if the load is not equal to apply so huge foundations. That's why we need maybe 5,000. Let's see, 5,000 is also enough. Up to 5,000 tons. Okay, 5,000 tons. In general, we need to find all total weight of our building and use that number here. So how to know it? We need to make the calculation, and after then the report about calculation will give us information about how many kilograms are weight all building. So we'll apply the second variant, apply. Now we'll need to select our foundation, select it, go to the C1, C2, next,